So I'm getting more and more interested in air conditioning, guys, particularly automotive air conditioning. So I've purchased a recovery machine. You can do what you want when you're servicing a car, but I try to do it properly. I try to capture whatever refrigerant is in the vehicles I'm working on. Typically, the stuff I'm working on is empty; it has a leak, right? But on occasion, it's not. In which case, you have to actually recover the refrigerant, right? So if you have a scenario where you have a car and it does have refrigerant in it, I think most of you guys know that R134A, the previous refrigerant that was typically used in cars of relatively modern vintage, the static pressure or the resting pressure in the system is typically in and around the same temperature value in Fahrenheit. That is to say, if it's 75 degrees outside, the pressure, the resting pressure in the system will be in and around 75 psi. So if your recovery bottle is not being used for the first time, that is to say there's refrigerant already in here, it will be at the same pressure. So what you have is a balanced system. The refrigerant's not going to want to move from 75 psi to 75 psi, right? Yeah, you can ice the tank. There's a few tricks you can use, but the proper way to do it is actually motivate the refrigerant through compression, liquefaction, and store it in the tank. Yeah, you can store it as a gas. You could compress it as a gas, obviously, and store it, but the quantity, the weight of refrigerant that you're going to be able to store for a given volume is going to be a fraction of what it would be if you actually liquefy it through a condenser coil, and that's the point to the condenser coil. So, as I said, what does this thing consist of? There's a motor that actually drives the compressor. The same motor actually drives a cooling fan that actually draws air through the shroud here, the housing. The box that actually contains the unit is open at both ends and actually drives cooling air through the condenser coil here. So this machine has the capacity to recover refrigerant, liquid refrigerant directly, or vapor. I'm only going to talk about the vapor because it's a wee bit more interesting. That's all. So there's a low and a high side gauge on it just to keep track of what's going on. Not a lot different than your actual standard manifold. And as I said, there is a condenser, not a lot different than this coil here. This happens to be an evaporator, but this is a condenser coil. We want to go from a gas to a liquid in order to store it, maximize the efficiency with respect to the mass, the weight of refrigerant we can actually store, right? So there's a suction and there's a discharge line. You can set your valves up for depending on whether you're recovering vapor or liquid, as I mentioned. You turn the machine on. Basically, the vapor will come in, goes through compression, because again, you're going to have to take the 75 psi, compress it so that it will want to motivate towards the tank, right? So we'll up the pressure, take it through the line, potentially on the manifold down here, behind here, that you can't see, guys, and actually put it through the condenser coil. And once it's condensed, it'll come through. You can actually discharge a liquid so that you can, again, maximize the storage efficiency and maximize the mass that can be contained in the recovery tank itself. So you might think offhand that the vapor will be at a certain temperature as it goes through the condenser coil here. There'll be a massive drop in temperature, and that's what actually causes it to liquefy. Well, to some degree that's true, but really what this is doing is removing the latent heat, not the sensible heat, but the latent heat, which then can actually, the refrigerant can change phase from a gas to a liquid with not a great deal of temperature change, theoretically with none, I suppose, but that won't be the case. There'll be some degree of subcooling with this, and then it comes out as a liquid. And of course, as you process the recovery, as the recovery is in process, you keep track of how much refrigerant is the tank here, because there is obviously a danger of overfilling these tanks, but that's a separate issue completely. If you think about it, it's really the exact same thing that's happening in your car, right? Where the vapor will come back from the evaporator. It comes into your compressor. The compressor ups the pressure of the vapor. That vapor makes its way into the condenser coil. The condenser coil then changes it, condenses the vapor into a liquid, and the liquid comes out of the liquid line. It's really the exact same thing that's happening on the high side of your car. So yeah, I thought some of you would at least be interested in getting a look at this. It's kind of an interesting rig. I'm hoping to have occasion to use it. As far as I know, I've got it fully functional. And it's quite simple, you know, as I said, compressor driven by it's an AC motor pump basically is what it is, and a condenser coil, a couple of gauges, a couple of valves to manage what's actually happening, what mode you're operating in, and a board that actually controls the couple of the control functions. You can have a sensor that goes to the tank at 80% capacity. It will automatically shut off the machine. There's a tank full sensor capacity, that's what the yellow cord is for, and there's a high pressure shutdown as well. There's a pressure switch here that you can actually see. So there's a couple of protection modes. That's what the LEDs are actually all about on the front of this rig. So anyway, that's just a quick look at the Yellow Jacket R60A. Never used it, full disclosure. I'm only an amateur when it comes to air conditioning. But as I said, guys, I endeavor to do things right for the simple reason that that's really where the most learning takes place. You know, everybody starts, you know, getting a ball and putting it in your car, and you think you're good to go, right? Well, there's quite a bit more to the story. So I hope this actually makes some sense, guys. It's all about actually being able to take the pressure which sits in a car, right? Whether it be gas, whether it be liquid, in a static condition. Basically, I'm going to be operating in a mode where I'm going to take the vapor, run it through the machine, it'll convert to a liquid, store it in the recovery tank as a liquid, and I'm hoping for the most part to be actually able to reuse it. I'm going to put a couple of filter dryers into the loop and be able to reuse the refrigerant that I'm using because, well, some of you guys know getting the refrigerant is another story here in Canada. But anyway, that's what's happening with this, guys. Some of you guys have seen it in a brief post I made there, I don't know, a couple of weeks ago. But yeah, this is what I'm all about currently. That's it, boys. I hope you found at least something interesting here. Oh, by the way, I should have mentioned just before I leave this. So it's all about this graph here actually shows you the temperature pressure relationship of R134A. So this curve here is actually where you're dealing with a saturated state. That is to say, you have both a liquid and a vapor right at the curve. Anywhere above the curve is a gas, as you can see in the drawing. Anywhere in the shaded area here would be a liquid, right? So what this machine will do is up the pressure and lower the temperature, get you into the liquid band here in order to be able to store it, as I said, at maximum mass, maximum weight in the tank, as opposed to just a gaseous or vapor state. That's it, boys. I hope that made some sense. I know some of you guys don't watch the channel for this stuff, but I can only produce material that interests me. Otherwise, I'm just going through the motions, guys, right? It's no about the money for me. If it was all about the money, I'd be producing hand-tech oscilloscope videos day and night. It's not just about the money. It has to interest me. That's it, boys. Cheers.